We've had a number of atmospheric river events across California over this last winter, and after each storm, I usually have people come up to me and they ask, like, what is an atmospheric river? And they'll ask things like, when did this term become a thing? Like, I never remember people saying atmospheric river before, and part of the reason for that is because it used to be called the Pineapple Express, and then the term atmospheric river was more of a scientific research term that came out in 1994, but then it's come into, I would say, more media communications and just overall society much more over just the last couple of years. But there are some benefits and I'd say downsides to this term. A lot of times when you hear atmospheric river, you just imagine torrential downpours, flooding everywhere, power outages. And while that is true for very severe atmospheric rivers, the smaller, less intense atmospheric rivers will actually be mostly beneficial to California. So I was thinking about this, and then I saw a paper that came out that's talking about categorizing the intensity scale of atmospheric rivers almost like a hurricane, where you have category 1 hurricane up to category 5. And I thought, oh, this is the perfect kind of answer to that problem of not being able to talk about atmospheric rivers without people automatically thinking it's a bad thing, because half of them, and actually the majority of them, are just beneficial. So that's a long way of saying a category scale has been developed by researchers for atmospheric rivers, and thought it would just be interesting to dive into that research just a little bit. So we'll go over to Meteorology Insider here. This is intensity scale for atmospheric rivers. Atmospheric rivers are long, narrow bands of water vapor that transport moisture from one place to another. They can deliver much needed rain or snow, but if they're too intense, they can cause flooding, landslides, and power outages in the western U.S. and elsewhere. So just a little background on that, because I've already said the term atmospheric river maybe 50 times in this video already, but I didn't really explain it. What it is, most of the time, is where you have a lot of direct sunlight at the equator. That leads to a large amount of evaporation. You end up with a ton of water vapor in the air, and then you'll have winds that'll come down and funnel that water vapor directly into California. Well, this happens all over the world, but I'm mostly focused in California. So what happens is we have coastal mountains, and as that water vapor bumps into those coastal mountains, the air is pushed up. As it's pushed up, it cools down. As it cools down, it can't hold as much of that water vapor, so it condenses into clouds, almost like you're squeezing a sponge. And then we get a very large amount of rainfall on our coastal mountains, and then as it keeps going into the state, it bumps into the Sierra and does the same thing with rain in the lower elevations, because it's usually associated with warmer air, because it's coming up from the south, and then snow up in the upper elevations. And these are very beneficial for California. We would be in big trouble if atmospheric rivers weren't a thing. About 3 to 5 or 30 to 50% of our annual rainfall for California comes from just a few of these atmospheric river events per year, and about 40% of our snowpack comes from these storms. So very important and actually critical to California's water supply. The drought, they're also called drought busters sometimes because they'll bring so much water, and that's what we've seen this winter. But then on the more intense side of things, they can lead to widespread flooding and power outages, which is what we have seen with the last couple in California. So a new study utilizes an intensity scale for atmospheric rivers akin to the hurricane scale to rank them from AR1 to AR5, with AR5 being the most intense, just like a Category 5 hurricane is the most intense. This scale can help determine whether an atmospheric river will bring benefit or cause chaos, and is helping meteorologists and city planners better understand the societal impacts of these events. So I haven't used categories on atmospheric rivers throughout the season because I only just found out about this paper, but it is a perfect tool, because we've talked about the benefit and the hazards with atmospheric rivers, and it would be very easy to just be able to give people a quick snapshot of what's going on, because that's where the term atmospheric river is very useful as a broadcast meteorologist, because it's a quick way of saying there's a big storm coming in. So then people know to listen and then know to prepare. And occasionally these can be life-threatening, so it is important for people to start preparing. But in the past, I've always wished there was a way to scale it back a little bit when it's an atmospheric river, but it's not really a big one. And that's exactly what this scale is going to allow me to do. In the future, I'll be like, Category 1 atmospheric river, it's going to be great. So, and it'll just help reduce fear, which I think is a good thing, when it's not necessary. With some of the storms that come in, fear actually is a little bit necessary because widespread flooding can happen and it can be life-threatening. So an atmospheric river is typically formed when warm temperatures create moist packets of air. Packets? I wonder if that should be pockets. Which strong winds then transport across the ocean. The intensity scale ranks these atmospheric rivers based on how long they last and how much moisture they transport. As a result, some West Coast weather outlets are using the intensity scale to help communities know whether an atmospheric river will bring benefit or cause chaos. So it makes sense that they're doing about how much precipitation is or how much moisture it's transporting and how long it's going to last. Because if it's transporting a lot of moisture, but it's only going to last 12 hours, we'll see 2 to 3 inches in the Santa Cruz Mountains. But if it's a medium amount of moisture over 2 days, that's where we could see 6 to 8 inches. So it's those two factors that determine how much rainfall you're going to get and whether it ends up being beneficial rainfall or not beneficial rainfall. And I would imagine the not beneficial rainfall is when we're seeing a large amount of moisture over a short period of time because it's harder for that to soak into the soils and it leads to more flooding. Something we've seen all too often this season. So the atmospheric river that contributed to disastrous flooding in Pakistan was an AR5. You may have seen some of the footage coming out of that. It just looked devastating. The most damaging, most intense atmospheric river rating. This underscores the need to know when these events are coming and how to prepare for them. To this end, F. Martin Ralph, an atmospheric scientist at Scripps Institute of Oceanography, and his colleagues developed the scale for the U.S. West Coast, and the new study demonstrates that atmospheric river events can be directly compared globally using it. So that's actually, you might not have caught exactly what they're saying there, but they're saying this scale should be the same over the entire globe, because if you didn't know, hurricane scales can actually differ in different regions across the globe, and that made sense when all of our communications weren't globally connected, but now that they are, it's much better to have some kind of category system where you're comparing the same thing and the same features and the same characteristics everywhere. This is actually a problem with red flag warnings too. Some offices, red flag warning just tells you how bad wildfire danger is, and different offices will have different characteristics for what the different criteria for a red flag warning. So it makes it a little bit confusing, but it also makes sense because 95 degrees in Death Valley is normal, whereas 95 degrees in the Santa Cruz Mountains would most likely lead to a red flag warning. So that's a bit of a tangent there. Basically, it's saying it's going to be a global categorization so that we can compare different events, because it's not, I always focus on California, but it's not just California that sees atmospheric rivers. So the researchers also found that more intense atmospheric rivers, AR4 and AR5, are less common than weaker events, and AR5 events with AR5 events occurring only once every 2 to 3 years when globally averaged. So that makes sense. You're going to have a lot more weak storms than you are going to have giant storms. Same is true with hurricanes. You see a lot more Category 1 and 2 than you do Category 5. And then the last part there is interesting. So they say Category 5 occurs only once every 2 to 3 years across the globe. So I'd say that's a good sign there. That's not that many. The most intense atmospheric rivers are also less likely to make landfall, and when they do, they are unlikely to maintain their strength for long and penetrate farther inland. So that's also some good news. You're not very likely to see an AR5, and then if you do, it won't last all that long. but that's also maybe why it's an AR5, is because you pick up all of the rainfall with that storm over a very short period of time, and that leads to a lot of flooding versus being all that rainfall being spaced out over a number of days where some of it can soak into your soils. So the study identified 4 centers or hotspots of where AR5s tend to die in the extratropical North Pacific and Atlantic, Southeast Pacific, and Southeast Atlantic. So it's, again, not just California that has atmospheric rivers. Cities on the coast within these hotspots, such as San Francisco and Lisbon, are most likely to see intense AR5s make landfall. So they're saying, yeah, a lot of atmospheric rivers make landfall in the mid-latitudes, and then it makes sense that if you're on the coast, you're more likely to see one of these events because all of this moisture was created from evaporation in the ocean. So then as it gets funneled in, it's going to hit coastal cities first. And then especially where you have some steep terrain or some topography where it'll lead to that effect I was talking about earlier where the air rises up, cools, water squeezed out like a sponge. So just continuing here. Additionally, the study found that strong El Nino years are more likely to have more atmospheric rivers and stronger ones at that. So that's something I didn't know. Apparently, in an El Nino year, you get more atmospheric rivers, and then the ones that you do get are also stronger. Good to know. I wonder if that's what happened in, I believe it was 2017, was an El Nino year where we picked up a massive amount of rainfall. I bet it was that exact sentence explains why that happened. And I think we're in La Nina right now, but I won't even go into that. I don't know. So the authors hope to see within 5 years or so meteorologists on TV around the world incorporating the atmospheric river intensity scale into their forecasts, telling people whether the atmospheric river will be beneficial or if they need to prepare for a serious storm. By better understanding the impacts of atmospheric rivers, we can prepare and mitigate the damage they can cause. So what they're saying there is over the next few years, they hope broadcast meteorologists like yours truly will be using this. And to be honest, I think it's a pretty great idea because I'm often hesitant to say atmospheric river, especially when it looks like it's a weaker one, because it feels like it might be overhyping things a little bit. But this is just the answer I'm looking for because I'll be able to say an atmospheric river, but then I'll be able to follow it up with it's a category 1. So it's going to be larger than your average storm, but it's mostly going to be beneficial. Whereas if it's one of those storms that happens only once every 2 to 3 years across the globe, like a category 5, then I'll be able to say this is a category 5 atmospheric river. This is the ones where we need to prepare. There's going to be flooding, widespread power outages, and it would just be very useful to have this category system. So hopefully we don't have another one throughout the rest of this winter. I think we've picked up enough rainfall for 1 year, even maybe for 2 years. But if we do, I'm going to figure out where they show these categories, and I'm going to use it in my next forecast. So hopefully you learned something throughout the course of this video. I know I did, and thanks for watching.